this point in time, you should have a strong understanding of the nitrogen cycle and the use of various fertilizers to supply the nitrogen needs for a crop. Now what we want to do is talk about a different subject focused on nitrogen management within ecosystems or agroecosystems. So there's 5 definitions. I'm sorry, 5 learning objectives that you should know by the end of this unit. The first one is to be able to define nitrogen use efficiency and simply know the common range or ranges of nitrogen use efficiency within crop production, both within the US and globally. Objective number 2 is to recognize that there are at least 4 practices that may improve nitrogen use efficiency, which includes proper application rate, proper application time, proper application location, as well as the use of specialized products. Objective number 3, you should be able to explain how nitrification inhibitors can increase the availability of ammonia or ammonium forms of nitrogen fertilizers, and you should be able to identify the conditions which would warrant the use of nitrification inhibitors. Now, you might even be able to tell me right now how this works and where it should be used. These products inhibit nitrification. So if you understand the nitrogen fertilizer cycle, you understand where this puts a bottleneck within the cycle itself. We'll keep that at that place for now. Objective number 4, very similar to number 3. In this case, explain what a urease inhibitor is used for, how it would benefit crop nitrogen uptake, and under what conditions would warrant the use of urease inhibitors. We've talked about the urease enzyme already, and you know that it is needed for the conversion of urea to ammonia / ammonia. So you know where the bottleneck would occur when using a urea or a urease inhibitor. Then the last objective is to explain how slow release, delayed release, or controlled release nitrogen fertilizers can help to enhance nitrogen use efficiency. So let's talk about the first learning objective for this unit. The first learning objective for this unit is focused on nitrogen use efficiency. And the definition of nitrogen use efficiency is simply the ratio between the amount of fertilizer nitrogen removed from the field by a crop as compared to the amount of nitrogen fertilizer applied. The efficiency or nitrogen use efficiency oftentimes ranges between 20 to 50% of the nitrogen applied is removed. But I can tell you that this range is all over the board, right? So let me share with you why this is all over the board, or at least in terms of how it looks on a global scale. So this slide shows you the nitrogen use efficiency for various crops in different places across the globe. So for example, corn in the north central US has a nitrogen use efficiency roughly of 37%, but the standard deviation is plus or minus 30. So we're talking about 67%, quite a range. Rice in Asia with no recommendation from researchers, i.e. taking a look at a fertilizer recommendation guideline, it ranges from 31% plus or minus 18. If, however, there is recommendations used from researchers or fertilizer guidelines, you can increase the nitrogen use efficiency. Wheat under unfavorable weather conditions, 18 in India, plus or minus 11, and under favorable, 49 plus or minus 10. It's all over the board. Okay, and you know why this is all over the board already if you understand the nitrogen cycle and the factors that affect the nitrogen cycle directly, right? So temperature and moisture conditions, enough sunlight, too much water, leaching, denitrification, volatilization, etc. These all factor in to what you see on this table on this slide.